Hello everybody, this is Mr. Reese again. I wanted to create a video on vectors. Um, Vectors are a mathematical kind of construct to help us understand certain quantities in physics. So basically what that means is vectors represent a quantity that has both magnitude and direction. Okay, so for instance, you can imagine like force. Like let's say you had a block here and there was a force going this way, and this force equals 10 newtons. And there was a force going this way, and this force equals 2 newtons. Then you might say, well, how much total force is pushing on the box? And if you think about it, yeah, you get 10 going to the right and you have 2 going to the left. So in total, you would have basically 8 newtons of force going to the right. And so, as you can see, the number matters here, but so does the direction. And the direction we denote with an arrow. And so force is a good example of a vector in physics. And there's a lot of different vectors. The next subject that you'll study is motion. And in motion, you can say something has a speed equal to 50 miles per hour. Or you could say something has a velocity equal to 20, let's say, meters per second east. And so speed is called a scalar, whereas velocity is called a vector because it has both magnitude, which is the amount, and direction. Okay, so you kind of get the idea what vectors are. There's a lot of different vectors in physics. I'm going to just create a new one, and I just want to talk to you a little bit about adding up vectors. And so when you add vectors, one way to add them is called graphically adding them. And that's like combining two vectors. And graphically means you do it on a Cartesian coordinate system. So if you had an x and a y, and let's say I change the color to red. Will it do that? Let's see. Okay. And let's say my first vector is vector 1, and let's call that vector A. And let's say you have the next vector, vector B, and let's say vector B is going to the right, like that. And maybe these are two forces again. So like in a system, if you had a block, you can imagine that block might have a force pulling it this way, A, but also a force pulling it this way, B. And you might ask, okay, well, what's the combined force on the two? Okay, and so when you're trying to combine vectors, what you really want to do is draw yourself a new coordinate system. And you put the first vector on there, so vector A, and you start with its tail. So if you think about it, on a vector, that's the tail, and that's the head. Okay, so you put the tail of the first vector at the origin, and whoops, and you draw that vector in. Okay, so then that's A. And then you take the tail of the second vector and bring it over to the head of the first vector, and you add that in. Okay, and so that's vector B. And I'm going to, in blue, put A plus B, which is this amount right here, A plus B. So really, to add two vectors, you simply take the first vector, put it on the coordinate system, take the second vector, put its tail at the head of A, and draw it, and then connect a line from the tail of the first to the head of the last vector, and this right here is what's called the resultant A plus B. Okay, now you can imagine you might have, let me kind of delete this. Okay, you can imagine you might have a third vector. So I'm going to put a new vector. Maybe it's vector C, and maybe vector C starts here and goes, let's see, switch back to writing. Okay, let's say vector C starts here and goes all the way down here. Change the size of this back. Okay, so again, vector C goes all the way down here. We'll call that vector C. And now you want to add up A plus B plus C. So we're going to draw our coordinate system. You always draw a coordinate system first. And we're going to put our vectors on here, okay? So here's A. And we're going to take B and put it at the head of A. And finally, we're going to take C and put C at the head of B, connecting down. So you just keep putting them in order. And so now our resultant in this case, if we're trying to find out what is A plus B plus C, right? So we're going to go actually from the tail of A all the way to the head of C, and this vector is the resultant of A plus B plus C. So in other words, if you were to add something going northeast to something going east to something going very far south, what you actually get is a southeastern resultant vector. Okay, now a few quick things. Vectors will often have little hats on them. Now, that sounds kind of funny, but basically, since they're not normal variables, they're vectors, these things will have little hats. So we can put them as little hats. And the hat is just a little arrow. And so oftentimes in a textbook, you'll see this. And the first time you see that, you think, oh my God, this is really hard. But actually, it's just little hats on there. So don't let that bother you. It does look different than normal, but that's because they're vectors, okay? All right, so that is graphically adding vectors. Let's move on. Okay, what if we wanted to find the components of A, the vector components? So in other words, if we go back to our coordinate system, all right, there's X and Y, and let's put A back on here. Okay, and let's say A is like this, and let's say it's 10 units long at 45 degrees. Okay, so you can imagine if this is A, and A equals 10, I'm going to put a little hat on A now, A equals 10, then you could also imagine that there's AX and AY. And AX would be this guy right here. That would be AX. And this would be AY. So A is a combination of AX and AY, making A, which is 10. So now we have triangles, and we have a right triangle now. So therefore, AX is equal to 10 cosine of 45. And AY is equal to 10 sine of 45. If you do those in a calculator, you get 7.07. Now, something to notice here, okay? In vector talk, you know, when you're working with vectors, you can say that vector A is equal to AX plus AY. That's perfectly fine to write like that. And we know A is 10. But if you add 7.07 plus 7.07, you'd get 14. And that's going to seem weird at first. These look like they don't equal each other. So when you write stuff like this equation is not like a normal equation, it's a vector equation. And it's basically saying if you were to add two vectors with an x of 7.07 and a y of 7.07, what you're going to get is a new vector worth 10. Okay, so The components of A are 7.07 going to the right and 7.07 going up. And when you combine those using triangle math, you get back to 10. And so you can take any vector and find its x and y components. Okay, so let's add two vectors using the component method now. So this is adding using components. Okay, so again, coordinate system. Let's say again, we already have A, so let's stick with A. So A is 10 units long at 45 degrees. And let's say B is also 10 units long at negative 45 degrees. Because we're going down, we're going clockwise. That makes it a negative angle. If you're going counterclockwise from the positive x, you'd have a positive angle, right? So let's say this is vector A, and this is vector B. So we can say AX is equal to 10 cosine 45, which equals 7.07, and AY is equal to 10 sine 45, which is equal to 7.07. We know that already. What about BX and BY? See if you can pause the video and come up with BX and BY on your own. Right. So if you do that, you would say, oh, okay, well, this is going to be 10 cosine of 45 again, which is 7.07. Because if you think about B, and I'll just take a minute here, B is going to have this piece, that's BX, and this piece, that's BY. So BY is going to be 10 sine 45. But what should I do here? Negative 7.07. Why? Because it's pointed down. So remember, with vectors, this is the positive. Well, just in math, this is the positive y, this is the negative y. This is the positive x, and this is the negative x. And so when you're doing these components, if the component is going to the right, this is positive. If the component is going up, this is positive. This component's also going to the right, so it's positive, and this component's going down, so it's negative. So we might say, oh, well, C is equal to A plus B. Okay, and if that's true, then CX should equal AX plus BX. This is all in vector talk. Vector math, right? And CY is equal to AY plus BY. So let's just do this out. AX, we know,